Hello, everyone. Welcome to 2021, the new year. And we're really looking forward to this new year in terms of all things aviation and aerospace, and trying to do our best to provide information and also networking opportunities for the next generation coming up into the industry. Some aspiring for it, some already in it. So we have a variety of you from middle school all the way to postgraduate, and already have started out doing a few things. And one of the things that, because I'm sure some people say, well, aviation and aerospace, well, avi aerospace is aviation, but the funny thing about it is they're in certain ways, they're very different industries. It just depends on the career path that you're taking. So if you're thinking about being a pilot or a mechanic or avionics tech or things like that, that tends to lean more in the aviation realm overall, whether it's commercial or private or business or whatever the case may be. And if you're thinking more in the engineering realm, that tends to be, I just feel like I'm going to be corrected shortly by our two guests. But anyhow, that tends to lean towards aerospace. So, and aerospace is a big deal these days, as everybody knows, with plans to go to the moon and to Mars. And, we've got folks going back and forth on the International Space Station via American transport, which is absolutely great. So, and I see Shonte is doing light effects over there. Did the sun just come up? Anyhow, speaking of our guests, let me go ahead and get started with introducing two really great guests that we have on the show today. First, I'd like to introduce Shonte Tucker. Shonte has been a guest on the show before. She is a systems engineering technical group supervisor. She will explain what that actually means. At the Jet Propulsion Laboratory, better known as JPL, out in Pasadena, California. Good morning, Shonte, and welcome to the program.
Good morning. Thanks for having me.
It's great to have you back on again, and looking forward to hearing more about what you do and how you got there and all of that kind of good stuff, and see if we can't help some of the young folks out watching the program. And then it is my pleasure to have both a friend and colleague and son of a very famous person, Ron McGee. Ron, his father is the infamous, the iconic Charles McGee, Brigadier General Charles McGee, Tuskegee Airman, who just turned 101, has had an amazing career, flying in 3 wars, has flown 37 or so aircraft in his career, except including flying just a year ago, and then prior to that in '99. So he's flown 3 small jets, civilian jets, private jets, since turning 99. So it's been pretty great, and he had a really great flyover of a P-51 Mustang for his 101st birthday. Ron has followed in his dad's footsteps in a lot of ways. He served in the Air Force. He is currently a global flight instructor for Boeing, and he teaches people how to fly the 777 and the 787 Dreamliner, both 2 great planes that I've had the privilege of flying on, not up front, of course, but as a passenger, but 2 great aircraft, 2 amazing aircraft, actually. And it's going to be interesting to hear his career path and the things that he's done for Boeing and prior to that and that type of thing. Ron, great to have you this morning.
Thank you very much. Pleasure to be here.
Yeah, great to have you on the show. So it's great to have both of you. You guys have some crossover a little bit with your engineering backgrounds and that type of thing. So it'll be fun to talk to you both about it. Let's start out a little bit. Let me ask you this, first of all, Shonte. We were talking about this prior to the show. Curiosity, how far is it from Mars? How's it doing? And how are you guys doing?
Well, everybody's doing really well. We have a lot of people that are working from home, supporting the various spacecraft and rovers that we're working towards Mars with, as well as the one on Mars. We have people that are actually going into work each day. They're working with the safe at work protocols. You know, we're keeping distance, people are wearing masks, and we're just persevering, which, you know, it's been a great term for us. Perseverance is the name of the rover that is currently on its way to Mars. And
Oh, why do I keep calling it Curiosity?
Curiosity's already there.
It's there.
Oh, I'm sorry. I got the two mixed. No.
You were fine. You were still good. You were still right in there.
Curiosity,
'Cause we're still taking
Perseverance.
care of
Okay,
that
so
one.
Perseverance is on its way.
Yes, Perseverance is on its way, and we're expecting a landing in February, and everyone's really excited about that. And it's been a challenge. I kid you not. It's already a challenge when you're on your way to Mars, even in the cruise phase, even when you're getting ready for your entry. You know, of course, when you're getting ready for your entry to sit landing, that is the real, you know,
Critical part.
terrifying time. But yeah, everything so far is going well, and Perseverance has been a name that's been it's really resonated with us in many ways. We didn't, you know, the young man that named the rover, he couldn't have foreshadowed how appropriate Perseverance would be this time in our country.
That's funny. So as a systems engineer supervisor, what exactly do you do, and how does that relate as an example to something that everybody can understand that's going on right now? You have a rover on Mars and you have one on the way. How does that relate to your responsibilities?
Well, that's a great question. First of all, systems engineering is, I like to think of systems engineering as like a bridge between different areas of engineering, right? So people can pursue degrees of mechanical, electrical, structural, chemical. You know, there's so many areas of engineering in which people can pursue degrees. Both my degrees are mechanical engineering. When you look at systems engineering, like say for instance, a rover is a great example. You have all these different subsystems that come together to make the rover. Like you have mechanical, which is like all of your mechanisms, your moving arms, you have your moving arm rather. You have cameras, which are like some of your science areas, and you have, you know, thermal, which keeps everything warm. You have electrical, which is providing power and electronics boxes and such. Thermal and systems engineers are the people that work across those subsystems. As an example, you may have a thermal engineer that says, I want a heater that's going to put out, you know, 15 watts, and this is what we need to keep it warm. And someone may say, well, you know, we don't have 15 watts to give you based on how we've allocated the power. You know, I can give you 12 watts. Can you make it work with that? You know, and the systems engineers are helping to manage the resources. And then you may have, you know, someone who wants to design a box that it's going to block the view of something else. And you're like, well, thermally, I need to be able to, you know, get this radiated power out, and you're blocking my way here. And then you've got the systems engineers saying, can you design that box maybe a little bit smaller so that we have the appropriate view factors for thermal? Someone who's helping other subsystems understand their impact on other subsystems. Like, hey, you know, thermal, when you do that, it really makes electrical unhappy. Maybe you guys can work together. It's literally that person who's working those different interfaces. You know, we work with external partners and internal partners at JPL, and we work those interfaces.
So I'm going to have some fun and cross over here. Ron, you're kind of a systems engineer. you teach people how to fly very complicated aircraft. What can you tell us about that as a global flight instructor for Boeing in two of the most sophisticated aircraft on the planet?
Well, it's really interesting because, yes, we're teaching the systems of the aircraft, but most of the time that's done, the systems actually is done in the background. They get to all that before they come to us. They know the systems before they come into it. We're really just teaching the flight portions of it, how to fly the airplane under the different formats and different types of approaches, et cetera. And the stall, we do high altitude and low altitude stall series, you know, that type of training. Really, it's a lot more of a human interaction than anything else, because the personalities are quite different. And of course, you know, the CRM, crew resource management, how do people who have a different background or different attitudes work together successfully and safely to fly the airplane?
So for you, it's almost a given. I'm sorry to interrupt, but it's almost a given about the knowledge of the systems. That's something that you do first before you actually come in to learn and train, and for them to train and that type of thing. And then you're looking more at their personality. Is that what you're saying?
It's a combination. It's not just the systems. We incorporate the systems into how do you they understand the basics of the systems. Now we say, how does that system interact with how you fly the airplane?
Yeah. So, a lot of young people have a tendency to look at something like either one of you, what either one of you do, and they say, okay, that sounds really, really complicated. So what do you say to people that are thinking about something that they're interested in terms of aviation and aerospace, not quite sure what they want to do, but they're good in math, et cetera, and so forth? Either one of you can take it.
Hmm. Well, I would say find your passion. A lot of times when you think about, you like math, you like science, when you have that in your mind, a lot of times that feels like this huge task. And like, one of the sayings that we use all the time is, how do you eat an elephant? One bite at a time. So a lot of times you think, oh my gosh, I really have a passion for, how circuits work. For instance, like nowadays they have all these really cool things that kids can mess around with. Like my daughter has this thing, it's called snap circuits. And you can actually build like little circuits in place. And then you realize you're like, wow, I really like looking at the network of how power transfers throughout a system. Maybe electrical engineering is something that I'm interested in. And so, as you go about, your experiences in math and science, you may find those things you have a passion for. Like for me, originally I wanted to be a pilot. And I just really loved planes. Eventually, I got to the point of wanting to be an aeronautical design engineer. And so then I realized, I'm like, wow, I really like, the wings. Oh, wait, what does it take to put a wing in? Oh, I like the airfoils. Oh, well, how do you design airfoils? Well, you do it in a wind tunnel. Oh, wow. Well, now I really like fluid flow over a foil. And so, what your interests are, you can start narrowing down into the areas that are the most interesting to you. So had I continued in aviation areas of engineering, and I decided I really liked the wing, of course, then I probably would have gone more into a fluid dynamics area and studying, the airfoil shapes to figure out what the wing should look like. And so as you find those areas you're interested in, you start, really, converging on what your areas are. A lot of times what you want to do from an engineering standpoint will jump out at you. So like with that airfoil example, I probably would have been a mechanical engineer, as I am, focused on, aerodynamics. So, find your passion and needle it down.
That's so important. That's so important. And in fact, it really doesn't matter what you do in the same things. It's that you're doing something that you enjoy doing, and there's a passion for you. And my dad has his 4 P's he always talks about, and it's perceive, prepare, perform, persevere. And the perceive is dream your dream and don't limit yourself. Good man, because people have expectations of you that it's not their expectations, it's your life, it's your dream. So whatever your passion is, hopefully follow that. That's the perceive, and then the prepare is learn as much as you can about it. Get all the education as you can in that field, and so you master all the knowledge that you can in what really interests you. And that's very easy to do because you're already driven toward it. That's your excitement. Aviation was that for myself. I wanted to fly since I was 5 years old, and I actually had a counselor in my senior year that called my mother and said,
I was hoping you'd tell that story.
He had expectations for me. He says, maybe Ron could learn to drive a truck. And I'm going to, what are you talking about, drive a truck? I'm going to fly airplanes. And so it was amazing. So of course I went on, fortunately, to fly it through aerospace engineering. But that was, so I got all the education I could in the field that I liked. And then the perform is don't accept anything less than excellence from yourself. If you just half try, then you're going to have to do a job. But so I always try for perfection the best you can. Some time ago, I gave a talk, and one of the things I said I thought was kind of interesting, is that my son came to me. He says, I got 99% on a test, and I thought, I said excellent, and then I started thinking about it myself and go, wow, is 99% excellent? I said, because if the airline industry was 99.99% excellent, there'd be a major accident every 4 days. We're 99.9 out to the 17th place, and yet we still think that's not good enough. So always strive for excellence. And then the last P is the persevere. Don't ever let anybody tell you that you can't do something.
Mhm.
You know, I heard a really good quote the other day. Matter of fact, the guy says, "If you aim at nothing, you'll hit your mark every time."
That is a really great quote. So, Ron, why don't you tell us a little bit more about your background? I mean, we know you're the son of a famous aviator, but and you just told us a little bit about being interested in flying since you were 5 years old. But how did you? What were the steps that you took in terms of your path to where you are now?
Well, fortunately, I knew at a very early age what I wanted to do. I was 5 years old, and I saw a bunch of planes in the sky at an air show, and I think my mouth hit the ground. I was like, "Oh my gosh, I've got to be a part of that industry somehow." Just like Shonte was involved when she got excited about the aircraft and the inner workings and how's that perform, how they fit together. So that was my first one. I had my first flight at 8 years old, and we actually flew through the clouds. And so I was above the clouds looking down, and I'm going like, "Oh my gosh!" It just fueled, added fuel to the fire and the excitement that I already had for the industry. But when I went through University of Kansas, I went through ROTC, and that was sometimes you have to make a tough decision in your life in order to achieve your goal. Because ROTC in the mid 60s with the Vietnam War going on was not a popular place to be. So I was not a popular person on campus, And,
Oh, wow.
yeah, not at all. So, but I needed to get that in order to get to my goal of going through the military, get military aviation. So when I graduated, I did go in and I went through pilot training and then went through F4 training after pilot training to George Air Force Base and was sent to Vietnam flying F4s, which my dad also flew the F4s in Vietnam.
He did. Let me ask you something though. Let's go back to your majoring in aerospace engineering. How did you figure out that was the major for you?
Again, my passion was to fly, and so or to work around and have something to do with aircraft and spacecraft. And so I've been to aerospace engineering simply because I wanted to learn as much as I possibly could about the field that excited me. And then if something physically happened to me where I wasn't able to fly, then at least I was still in the industry that excited me, that inspired me.
Okay, so you were in the Air Force. You flew F4s. Ironically, your dad did too. That's pretty cool.
Yep.
Yeah, and then you progressed from there in other aircraft.
Yeah, I went. Well, I got back after Vietnam. I ended up flying OV-10s, and that's a long story for that one. I don't think we have time for that story. But anyway, I ended up flying OVs in Bergstrom, and I didn't really like that, so I decided I wanted to get out and go to commercial. And at the time, there were very few commercial, black pilots.
Is that what made you make the transition? The type of flying you were doing at that point, you decided to go civilian?
It was a combination of things. Yes.
Okay.
I mean, it was that and an instructor, not an instructor, a commander who took a dislike in me simply because of my last name happened to be the same last name as his hero in some book, like a James Bond type figure. And so for me to show up in his squadron with the last name of his hero and being black at the time, it was a fairly ugly experience. And
Wow.
I just thought, I don't need to go through this. Like I said, it even gets more detailed than that. But we don't have time for that here. So anyway, so I decided.
Yeah. That's unfortunate to hear, but it's a reality.
It's a reality, exactly. And I knew I wanted to stay in the industry, so I started looking commercial. And when I got on with Brandon Fair Alliance, and I flew with them until, unfortunately, after 82, they went down, and I got on with Continental. But I missed also the military type flying, so I was able to go back into the reserve unit flying the A-10 Thunderbolts. And that was an outstanding experience. Definitely the best unit and the best experience I ever had in my military career.
What kind of aircraft is the Thunderbolt?
It's a twin engine, fighter, slow. A lot of people say, well, it's slow, at least it's ugly.
Well, I meant what mission? What did you do with them?
Primarily coast air support. The aircraft was designed to destroy tanks, and actually in Europe it was designed for the Fulda Gap area around Germany. But they found so many other uses for it in the Afghan War, in the first Gulf War, and everything else. The airplane really proved itself. It's still in the industry today, and probably will be for some time. It's an airplane built around a gun for the most part, and that gun would never be replaced with something else.
Yeah.
And
And then you are also flying for the airlines, and we'll come back and talk about that a little bit. I want to go to Shonte, and Shonte, I wanted to ask you a little bit more about your background, because it was interesting what you said earlier. Well, two things you said interesting. One is your daughter's already kind of, and sounds like an engineer in training. She's playing with the device you were talking about. But you were exposed to aviation through a unique factor with your mom. You want to tell us about that and how you got into you wanted to be a pilot, and you at the same time you had an interest in engineering, and you were kind of figuring that out and also taking advice from your mom, who has worked in the industry a long time.
Yeah, it's really interesting is one of the great things I learned from my mom was networking. My mom was a technician at Lockheed Martin, and she's been there for about, oh goodness, about 47 years. And now she works in an inventory role where she helps to get the parts ready for, various plane repair and such. But, when I was growing up, she was a technician, and she was around planes all the time. It was really cool because, I later learned after things were declassified, I later learned that she worked on the Blackbird and that she worked on some of these really cool planes. But just growing up, these were just pictures of planes that she brought home. And I remember looking at the Blackbird and the U-2, and I just thought those were the coolest looking planes. Now, I know Lockheed makes lots of planes, but those were the two that I just thought were the coolest planes. And I liked the idea of recon. I thought recon was like the coolest thing. And I'm like, oh, I want to fly. My mom's like, what do you want to be? I want to be a pilot, and I want to fly the Blackbird and the U-2. Those are the two. And so my mom just kept bringing home those pictures, and they continued to encourage me. And I was like, oh, this is great. At this point, I'm like 8, 9 years old. I'm like, this is what I'm going to do. And then as my mom saw that I was getting more serious about it, she's like, okay, I'm a little nervous here. You're my only child. I don't think I want you to be a pilot. And, as the saying goes in our family, if mom ain't happy, nobody's happy. So I said, okay, well, saying. What am I supposed to do? And so she said, how about you design planes instead of fly planes? And I thought, oh, okay. Well, I learned more about that. And I said, well, fine. If I can't fly them, then I will design them. I will be an aeronautical design engineer. And so my mom, she's a proud mom. She's talked to her friends at work, this is what my daughter wants to be, and what are the things she needs to think about. So that's where the networking part came in, because she was a technician. She wasn't an engineer. So she didn't know about engineering, but she knew engineers to talk to. And so she talked to engineers at work, and they said, aeronautical, well, how about she go mechanical? Because if she goes mechanical, she can do aeronautical, she can do aerospace, she can do all these things. What she wants to do, she can actually do with the mechanical engineering degree. And that degree will also allow her opportunities outside, aeronautics and aerospace and it'll buy her all these other options. So she decides she wants to go work, so, do something else, designing, computers or something, back then, I mean, the computers were like the size of my living room, but, he said, if you want to do those kind of things, she can do that. And so my mom came home and talked to me about mechanical engineering, and I was sold. I was like, that's it. That's what I want to do. And then I went on a tour of JPL when I was a little kid, and I was like, okay, airplanes are cool, but that is cooler. That's going to space. Oh my goodness.
So it was the exposure that both with Lockheed and at JPL that really locked it in for you, along
Absolutely.
with mom's encouragement. So when you were in school and studying, did it feel natural to you, or were you comfortable with it as you progressed through the training, the education?
Yeah, math and science were things I always enjoyed, and those were areas I excelled in. Growing up, my mom wanted me to have the best education. So all the way until I reached high school. So I guess I would say through junior high, my mom sent me to private school. And, in private schools, I was always one of just a few, Black kids. And unfortunately, I ran into a situation in which I had a teacher who she wasn't too fond of the Black and brown kids. And it was very obvious, and it was very frustrating. And all it did was heighten my interest in math and science, because she could be very subjective when it came to my English assignments or history assignments. But with math and science, it's right or it's wrong. So you can't tell me that 2 + 2 isn't 4, or,
Right.
4x +
Wow.
2, or what have you. So that helped me tremendously. And
Yeah.
one thing I tell kids about math and science, a lot of people see that as a barrier to getting to engineering. Now, you have to be good at math and science. You don't necessarily have to like math and science. So sometimes math and science,
That's an
for
interesting
some
point.
people, it's the necessary evil to get you to doing the cool engineering stuff that you want to do. So I have friends that actually they're like, I can't stand all this, but I know this is what I got to do if I want to do that. So
That's
I
why. That's kind of why I asked you. I wanted you to share exactly what you just did about how you personally dealt with it, but your perspective on it. And I think a lot of young people need to hear that, especially if they're still in high school or they're in college and they're just getting started. That there are courses in certain areas, in this case, math and science, that are important for what they want to do down the road. And it may seem, it's, I guess it's like anything else, medicine or whatever, you got to go the tough road with what you have to learn to get to the cool stuff and that
yeah.
type of thing.
One thing I will add to that, because it's more relevant now than it was when I was growing up. I'm officially one of those people. When I was a kid, but I'm officially there now, which is
Telling on
frightening.
yourself, you're telling on your age.
Yeah, right. But, getting kids to take programming classes, learn how to program. I mean, it's not necessarily which language do I pick. Do I take C? Do I go to C#? Python, Perl? What am I learning? The most important thing is to get some exposure to programming. Like my daughter took her first programming class when she was 5 or 6 years old. I mean, it was very, very low level. It was like, the scratch programming, like they were programming like a kid moving through the mall. Just
Are you
very,
talking
very,
about coding actually?
yes, computer coding.
Yes. Yeah.
Yes, so getting some exposure there, because early on, it's not so much which language you pick, it's understanding what it is to build a computer program. What are the things, what are the steps I need to work through if I want, to create this random number generator, which is one of the first programs that you would write, like in Python. And it's never too early. My daughter just turned 12, and like last summer, she took her first Python class. So, the opportunities are out there, and it wasn't very expensive. And there are actually some classes that you can take online that are free. So I just really encourage people to start getting that level of exposure, because that's where we're moving.
I'm
Yeah.
going to add to that, and this may not be politically correct. I apologize in advance. But a long time ago, I had a cartoon that was in the paper. I pulled it out, and I was so impressed by it that I cut it out and stuck it on a refrigerator. And what it had was a 2-part cartoon. The left side had a bunch of obvious Asian students that were designing computer games. And on the right-hand side, it had a bunch of Americans that said USA playing computer games. And I thought to my kids, which side do you want to be on? Because you want to be on the design side, not just a user. You want to be a developer. Like you just said, get a programmer or whatever it might be. You need that basis and that foundation, and everything else is built on it. The world's becoming more and more automated. In your automobiles and your aircraft, everything. However, there is technology and behind that automation.
Exactly.
So you want to just be a user, or you want to be a developer?
Yeah. And I would use the analogy that it's just like music. You can play an instrument, but if you don't know how to read it, if you don't understand the notes and what the core of music composition is, then you may have a natural instinct for playing, but you'll never fully understand what you're actually doing. So I'm glad both of you are putting an emphasis on that point. I think one of the things that is a challenge for kids today is also, well, they have a lot of challenges, but I think one of the big challenges that kids have today is trying to navigate through the things that you guys have experienced, that I myself has experienced, in terms of differentiating between what's good advice and what advice you may want to push aside or ignore, or that type of thing. Because I think both of you and everybody I've ever had on the show so far, one common denominator is that they have had guidance from people that have steered them in a good direction, even when they weren't sure exactly what that direction might be or what they were going to exactly do. So, you know, as an example, Ron, I'll come back to you. You came out of the service, you started flying for the airline, but you also missed certain aspects of the service. So then you added back in the reserves. So that helped you fulfill that, but then you continued to fly for the airline and that type of thing. And so I don't know if you want to comment on that, because I was also going to ask you when you made your transition after you retired from the airline to become an instructor for something as important as, you know, those two large aircraft for Boeing.
Well, I wasn't ready to retire. I was actually lucky because, you know, airline pilots used to, mandatory retirement was age 60. And I made within a year, I made it to the 65, so I could go to 65 instead. And I still to this day don't know what happens at midnight on the day of your birthday. You know, and you one minute before that, you're the most experienced person they have. You know, you've seen it all, you've done it all. And then 1 minute after, you're like, oh my God, you could die at any moment. Your mind's gone. So I wasn't ready. I wasn't ready to retire. I wasn't ready to give up my passion. You know, I wasn't ready to quit what I wanted to do since I was 5 years old. And so I started looking around. What can I do? I had been instructing 10 years on the 777 and 2 years on 78, 5 years on DC-10. So I've been instructing for a long time. And I thought, well, maybe I can do that. And so I started looking around, and CCL Aviation worked with Boeing, and applied for that, and you know, got on right away. So it was just continue doing what I love to do. I don't get to fly it, but at least I'm stretching it now.
So none of this has been work for you.
It's, you know what, it's work, but it's enjoyment. That's why I said, find your passion, what you love to do, because then you don't think of it as work. And I tell my kids now, people say, oh my God, I have to go to work. You know, change that, change your mindset and say, you know what, I get to go to work.
Yeah.
It's not something that you have to do. It's something that I want to do. I look forward to it. So I get to go to work. You know, it's not that I have to.
So dealing with a little reality here, we have had one heck of a 2020 with the pandemic, et cetera, and so forth. It has really affected a lot of aspiring aviators, kids that are in school. You know, I'm 21, 22 years old. I'm about to graduate. I've finished all of my flight training that I can do in school, and now it's a matter of building hours, et cetera, so forth. So I'm going to put this to you first, Ron. You know, what advice do you give to those kids that are kind of contemplating what their next step's going to be and what direction they should go as they wait for the industry to come back around? Because some of I've had students on that were on track to go into one of the programs with United or American or whatever, that would eventually have them flying right seat in a commuter and working their way up. And that's been, you know, placed on hold, except for a very few lucky ones.
Right. Well, you know, unfortunately, because of the year that we've had with the COVID and what it's done to the industry, that is a fairly major problem at the present time. However, that is going to, you know, get better with the vaccine. Once this finally gets distributed, it might be another year, it might be another year and a half, but eventually it's going to start building back up again, and it's going to have to. And when it does, there is still a shortage. There are a lot of pilots that are laid off right now, some of which probably won't be coming back. They were near retirement. I know from the airlines, they've offered a lot of early outs to people, and quite a few have taken it. But the U.S. alone is going to have a 50,000 pilot shortage within the next 7 years.
And growing.
And so, yes, this is a tough time now, if that's what you want to get to because of the COVID and what the shutdown has caused. But that's a temporary thing. It's not going to be permanent. And when it comes back, there's going to be a huge need. Getting on with the commuter is always something, you know, good to do when they start building back up again, because the majors are going to take everybody from commuters that have the experience, the 1,500 hours minimum in time. They're going to pull everyone that they can, because they have to. The pool isn't there for them, you know, to draw from, which means that the commuters are going to have to be hiring a lot also, and maybe lower some of the requirements, you know, to get on with the commuting. Because
another emerging market also, I say emerging in the sense that cargo has grown significantly, a lot of it because of COVID, but a lot of people are ordering stuff online and it has to be delivered. And so you're seeing the cargo industry really step up at all levels. And I think it's important to point that out because we're not just talking about a 747, cargo aircraft, but we're also talking about the little Grand Caravan that Cessna makes, and they have a new one that's coming out, and I forget the name of it. And then there's other smaller aircraft that are also are cargo capable and are being used for that now to run
Right.
small packages real quick, particularly in rural areas, et cetera, and so forth.
Flight for Life has actually picked up somewhat. Where you're on call to fly people from rural areas into hospitals that they might need it. A lot
Right.
of people have gone away from the commercial aviation because of the cutback and gone private. I know you know about that. So there are a lot of private corporations now that are air taxis, kind of almost. Where people
Right.
I'm going to hire and fly my own private jet or rent this
Right.
private jet to take me where I need to go. And that industry is actually increasing in size also.
Yeah, a lot of that is for safety too. Real quick before I go back to Shonte on something, any perspective on the drones now that are a whole industry in itself that's booming?
Which type of drone?
I guess the commercial drones. Yeah, you got me on that one. They are everything from the little personal one too, but I'm thinking more of the commercial ones that are going to be used for package delivery and then things of that nature.
But it's a slow process. I think eventually they probably will occur. The FAA under the Part 107 operation, which covers the drone operations, is being modified almost daily, and to try to expand that. There's a lot of industry now, or not say industry. There's a lot of technical support that's being put into the drones to make them compatible with aircraft, so they can know where the drones are, and they actually will talk to each other. And there's talk about the highways in the sky that is still being built right now, so that when the drones do it, they'll have a lane that they'll be able to fly in. Everybody know it. So I think eventually you probably will see something like the delivery, but there's still a lot of things that have to be worked out. The battery lifetime, of the drones, the flying over people, regulations of the drills and drop off. There's so much in the background that has to be taken care of. Is it coming? Yes. Is it going to be next week? No. But it's definitely on the way.
Yeah. Shonte, you had mentioned earlier when you were talking about the challenges that you guys have had the way you've had to mitigate the challenges of COVID with people working from home and that type of thing. Can you give us a little bit more insight on how that's affected, operations and that, what you do in your world?
Oh my goodness, it's been a tremendous effect, because a lot of us, like for instance, if you work on projects, like say for instance, Mars rover project or Europa Clipper, which is one of our spacecraft that's going out to one of the moons of Jupiter, a lot of times your systems engineers and some of the other people that support the flight system build are co-located. And you're used to just having a problem and saying, I'm just going to go walk over to someone's office and we're going to stand by the whiteboard and work out this problem. You're so used to doing that. And that's part of the reason you are co-located. Now, on some programs, I should mention that, sometimes the mechanical engineers stay with the mechanical engineers and electrical stay with electrical because they're working on their box or they're working on their mechanism and, before it all comes together. But
Sure.
The systems engineers and the people that are largely trying to bring it all together sit together. And we solve a lot of problems standing in front of the whiteboard or standing in a conference room where, people are collaborating in real time and say, hey, look at this number on my computer. And what do you think of this? So that aspect of things is gone because we have to social distance. Now, we do have some people that still come to work every day because they work on test beds or they work in test chambers, and you just can't do that at home. And so we still have that element. But when they get results, they have to pass those results on to people that are sitting at home. So we do use we use WebEx. We don't use Zoom. We use WebEx, and we have meetings very similar to what we have here. And we share screen. We do those types of things.
Okay.
It's still the same. I will say there are some areas in which we've been able to be really successful in getting these things done, but there's still areas where that physical presence does not allow us to be as productive. but we work around it and we continue. Like for instance, in building the last part of putting the rover together out at Kennedy Space Center, we had people that had to deliver the sample caching system, which is going to capture the samples that will later send another spacecraft to capture and return to Earth. But that wasn't done before they shipped. And so someone had to work on it at JPL. Someone had to make sure it got shipped to Kennedy. Someone had to install it. And you had people that were very close together. And they have different protocols on how they work safely. So we had those people wearing N95 masks. We had those people that had all the extra PPE protection. And then also anytime you're dealing with a spacecraft that's going to land or that's going to be near a planet that or a body that we think may have life, you have to have special, protection for yourself from it so that you don't take life and come back and say, we found life, and it's somebody's hair. So, I mean, you have those layers of protection you have to have anyway, but then you have that added layer to protect from the transfer of COVID. And so there have been a lot of things we've had to put in place. There's been a lot of spacing. Even the people that are working together at work are not right next to each other. You can only have so many people in a room. So even at work, there are people that are communicating like we are, but they're just, rooms away, and they have things at work that they don't have at home. So they have to physically be there. So it has been a challenge. It adds a special element to your task. If someone may have been exposed, then, that person who may have been working at work has to leave for 14 days, and everyone they came in contact out of an abundance of caution has to leave, and it's a disruption, and who's available, and it's a lot of shuffling. So it's an added thing to your day.
Yes. Do you think the post-COVID, because you have the ability to work from home instead of everyone having to be there using a whiteboard, et cetera, post-COVID, do you think that you will have a increase of people not having to be on station and working from home?
I think so. I really do. Those questions are coming up now. There are some people that really, really enjoy working at home, and they're great at working at home, and that's wonderful. And we want to allow that to happen. There may be some people that, decide, I do this really well 2 days a week. And so maybe we make the opportunity for people to do that, and it helps with traffic, it helps with parking. Parking is one of our biggest problems at JPL. People are like, what's your biggest space problem? We're like, parking spaces. That's our biggest space.
Wow.
So it certainly makes that better. So I think there will be people that take advantage of it. Me personally, I do not like being at home. I want to be at work. I want to walk around my clipboard.
I hear you loud and clear on that one. No offense to anybody here in the house, but anyhow. That's a great question, Ron. But I was going to ask you, Shonte, I want to shift a little bit. And I want to ask it from two perspectives. The first is from a high school perspective. So you're in high school, you're really good with STEM, with math and science and that type of thing. You know all about NASA because you've heard a lot about it. You've never heard of JPL before. And now you've heard something about it and it piques your interest. What's the first step for a high schooler to find out more or to become more engaged or involved with the possibilities at JPL?
Oh, the power of the internet. Oh my goodness. You go to the website, jpl.nasa.gov. You go to the website and you just start looking at all the different missions. I mean, even as a JPL employee, I sometimes go through and find things. I'm like, oh, we did that. That's amazing. There's so much information there. There are times when you may get in there and you're like, oh, I was looking for missions, that were Mars orbiters, and then you start finding Mars landers, and then you start finding Mars rovers, and you just start seeing that there's so many different things. I've seen, I've heard stories of people going in, I'm like, I'm looking for Mars stuff, and then they find out about Voyager, and they're like, oh my goodness, that thing is still going, and it's on the power of a light bulb, and they realize that might be an area they're more interested in. There are certainly opportunities. I'll say there will be opportunities again post-COVID for people to go on tours, and you can learn about that. There are opportunities for kids that are like being homeschooled. Like there's independent study type opportunities for people to have unpaid internships. There are internship opportunities. I started as an intern for JPL. I interned for 7 summers and then turned full time. I started
7 summers?
7 summers.
Wow.
I started right after I graduated from high school. I had my
You had
first
JPL on the brain, huh?
Absolutely. I knew when I was 10 years old, after that tour, I was like, this is where I'm going to be. And
Yeah. So let me ask you something that's pretty cool. Let me ask you something real quick too. The other part of this question was, so take a person in college that either is about to graduate or just graduated with, say, a degree in aeronautical science or something. So it's not an engineering degree. And they're having second thoughts about what may happen to them on the professional pilot track. And now they're thinking of looking at other aspects of the aviation industry, such as aerospace. Is there a place for them in a JPL environment?
Absolutely. You know, a lot of times people think you have to be an aerospace engineer to work in aerospace. You know, and it's interesting, company to company. There are some people that have a degree in aerospace, and there are people that have like a degree in mechanical, electrical, but they work in aerospace and are still considered aerospace engineers. So, you know, titles, I always tell people, I'm like, do not let the title dictate what you think you have opportunities, you know, where you think your opportunities are. If you've studied the courses, like one thing I tell people, like when they put their resume together, if they're worried about, you know, not being considered for certain roles because of their discipline, you can actually list relevant coursework, and you list the courses that you've taken, and it shows people like, oh, you took a fluid dynamics class. Maybe you could work in our CFD, our computational fluid dynamics area. And so it's more so what education you have, what capabilities you bring to the table. I mean, we hire people with all types of degrees, and then where you start isn't where you end. You may come through the door, like I came through the door after I graduated with my master's degree doing thermal engineering, working specifically in a subsystem. I decided I wanted to do something more systemsy, so I moved into instrument systems engineering. Then I decided I wanted to do payload systems engineering, so I moved into that area. If you have the skill set and you develop that skill set over time, where you start isn't necessarily where you end. We have people that come through the door with a math degree, and you think that, okay, they're going to do, you know, some theoretical
Calculations.
Exactly, that's what they're going to do. But you also need those theoretical calculations for attitude control. I mean, so it's not like you're just going to sit there and do that one thing. And the most important thing is that right now, kids in school, they're training for jobs that don't exist yet.
There you go.
The industry is constantly changing. I spoke to a machine design class probably a couple years ago, and I told them, I was like, you know, earlier this year I went to the dentist, you know, because I had to have a filling replaced. And I remember when I got my first filling, like how they had that little gray matter that they were beating into the back of my tooth back then. But this time, my dentist says, you know, he tells me to open up, he takes a camera, he goes in, and then, you know, they use CAD to actually develop what the actual filling should look like. And then he sent it to his lab in the back, and he had like, you know, an actual like 3D, it was almost like, you know, almost like an NC mill, if you will, but
Right.
for a filling. And, you know, they used computer aided machinery to generate this filling. And then he brought it in and put it in. And I'm like, that didn't exist when I went to college.
Yeah.
And now this is a technology that people use, and they use it in a dental office. It's not someone using a 3D printer or mill to mill out a shape of something to build with. There are endless possibilities in engineering, especially like when you look at computer science, like, you know, video game developing, that wasn't even something that was on the radar for a lot of people.
Ron, I see you biting at the bit.
Well, I'm just saying, life, you know, the kids, first of all, are getting smarter every generation. There's so much more information that's available to them, and they're forming at a younger age, so many more neurons in the brain connecting, you know, that they're just bombarded with the information. Like you said, when he came out, if I wanted to find out information, you know, Shonte saying, well, we go to the internet. You know, there was no internet. You know, we had a whole encyclopedia book. Of course, that's pretty limited. You go through that, and that's very limited. You know, and there's no place to go. You go to the library, but what do you look for? So with the internet now, there's so much more information, and it's changing so rapidly. You know, the whole technology industry is exponential in its growth. If you look from what's transpired from the last century, you know, from the first flight in 1903 to putting a man on the moon in '69. Are you kidding me? And now we're talking, you know, we have not only moon missions. I know NASA's going back to the moon in 24. I'm sorry, 24. And there are missions planned to Mars, manned missions planned to Mars. There's a company now, it's called Voyager Station, which they're going to, in the next 4 months from now, I think 3 months from now, they're going to do the first concept proof. And this is building a very large station. If you know what Voyager Station is, they're building a very large station, approximately 10 times larger than the space station. And it's going to be even larger than that because they can add on to it. But it's so people can actually travel into space for longer flights, even beyond Mars. But they're also going to have it rotating. So they'll have capsules rotating, so you're in space, but you have artificial gravity. So the things are just changing so rapidly. What's going to come in the future right now that it's literally wide open. You have to think outside the box. And I'll give you a good example of that. I like what you said, Shonte, a little while ago about what's your biggest space problem. You said parking space. I have a good friend of mine who works for Skunk Works.
That's where my mom is.
Oh, excuse Skunk Works? Oh my God, amazing. So
Palmdale.
Palmdale, there you go. So he said, you know, how many ships can you name? And he said, if you said battleship or destroyer, he said, give yourself an F. He said, if you said submarine, give yourself a D. He said, if you said airplane or airship, give yourself a C. And he said, you know, if you said spaceship, give yourself a B. He said, and if you said relationship or something along that line, he goes, give yourself an A, because you're thinking outside the box. Don't limit your mind. If I said ship, you think ship. He goes, no, it says open yourself up. Think outside the box of possibilities.
You chip off the old block from Dad.
I would never, no one can fill those shoes. You know that.
Yeah. While I have you, Ron, I wanted to ask you this too. I get this question a lot, and that is military or civilian route for flying. There are people that are in school that are going the civilian route. Sometimes they'll consider the ROTC aspect of it. And I've just had some on the show in the last couple of months that have specifically said that they're really caught between which route do you go. Ironically too, by the way, a lot of people think that don't know a lot about aviation think that military is the only way you can go to achieve a career in aviation, and we know that's not the case. But I just wanted, with all of your experience on both sides of the fence, hear your perspective on that.
Well, it's interesting, you know, times have shifted somewhat. When I first got on, if you didn't come out of the military, about 80% to 85% even of the pilots when I was hired were all previous military pilots. After the end of Vietnam, when there weren't that many people going into the services in the piloting field, that started to shift. And now it's actually probably about 50-50, people who had previous military experience or people who didn't. I can't say one is better than the other. It's what is good for you. Again, what your dreams are. However, I will say this: it's very difficult to compete with the military type of training that you receive. I know when I went through, and this is some time ago, that the military paid $1.7 million for my training, and it's a lot more strict than it is on the commercial side. We had testing every not every day, but we had learning a classroom, something half a day, and we'd fly for half a day. And that'd be 1 week, then we'd swap around, maybe fly in the mornings and roost in the afternoon. You get tested weekly. And the program lasted over a year. They call it the year of 53 weeks. So so it's very intense and a lot of training. You get into every aspect of flying, of aviation, of weather, instrument, and it's challenging. So that is it's hard to compete with that in the civilian world. In fact, you can't compete with that in the civilian world because it's a totally different type of experience, knowledge, you know, that's required to complete the program.
So I've had a question I've always wanted to ask you too, Ron, and this is coming from me as much as anything else. In terms of the military currently, they're challenged with recruiting new pilots. So much so, I mean, the Air Force is number one in that, but the Navy's had their challenges and the other services have too. What is happening these days that are keeping young people from pursuing just what you just said, an opportunity to get a year or whatever of flight training, plus you can then specialize in an aircraft, and then you can fly on someone else's dime and you know, enjoy it, et cetera, and so forth. But you know, a lot of kids just don't want to go that route,
Yes.
apparently.
I think one of the things in fact, I was looking at this myself just recently. Technology is changing so rapidly now that we're getting to the point where the planes are going to be autonomous and they're not even going to have a pilot. I know that there are already some aircraft that have been flown remotely. We have drones, of course, flying over the world right now that are flown remotely. You're not actually in the aircraft. You may be flying, but you're not attached, you know, in the aircraft itself. And that's going to continue to increase. Most of the fighter airplanes right now, believe it or not, they're limited because of the pilot. The airplane can perform a whole lot more than what it's doing because it knows that you as the human can't sustain what I can do. And that's as a lot of people I think probably turned off some of it too, because they are going more and more and more toward automation. And the fact that we are, you know, military, obviously, if you're in a war or have something, you have a need. And so they'll hire a lot more, but without a war, then that need's not there. And so you go in and you get a desk job or something like that instead of staying in the flight. And my father was very lucky. He got to fly 28 of his 30 years in the service. That's very unusual, very unusual.
Yeah.
You know, most people, if you get to fly for half of the time that you're in, you know, that's good. So again, I wanted to fly long term. I mean, that's all I wanted to do. So for me, staying in the service would not have been a good answer anyway, because I wanted to get something I could continue to fly for the career.
Yeah, we are almost out of time, and I wanted to give both of you an opportunity to say a closing statement about advice that you would give to our aspiring young aviators and those that are interested in both aviation and/or aerospace. Start with you, Shonte. What are your closing thoughts?
My thoughts are just really take as much math and science as you can. Take as many programming classes as you can. It's never too early to start with programming. I will say I'm surprised at the level of exposure that some of these kids are getting to the higher levels of math before they're getting to high school. Like, you know, my daughter starts geometry like in 8th grade. You know, that's their plan at the school. I mean, for me, it was a big deal to actually get through algebra. And so my feeling is just take advantage of those opportunities. And when people give you opportunities to maybe take an unpaid internship or something, absolutely do that. Getting experience in the field that you're interested in is very, very valuable. It's valuable from the standpoint of, wow, this is great. I see the real application of this math and science. I see why this is important. I understand this. I like this. It's also important from the, wow, I thought I wanted to do this, and gee, this sucks. I don't want to do this again. That's important too. An engineer once told me, not only is it important to know what you want to do, it's important to know what you don't want to do. So I really encourage you to get as much experience in those areas as possible. And if someone wants to give you an opportunity, you know, based on like, you know, we don't have a whole lot of women that are doing this work. We don't have a lot of Black and brown people that are doing this work. It does not matter how you get your opportunity. It's what you do on the other side of the door when you get that opportunity. Math and science, engineering, these are things that if you don't deserve to be there, you will wash out. So it's not like, oh, someone's just giving something to me. You're going to work for it. You're going to have to persevere if you want it. So when an opportunity is put before you, grab it and take advantage and make the most of it. So that's what I would impart to you.
You just make me want to say amen, sister. Ron, we're on final approach. What thoughts do you have?
Well, I would just dovetail on everything that Shonte just said, because that's exactly it. Find, hopefully your passion, particularly if it's in the STEM, one of the STEM area, then learn as much as you can about it. Dad's 4 Ps are great. Have your passion and stay open-minded to what that passion might be, but have a passion, learn as much as you possibly can about it. Do your best at what you're trying to do on it, work hard towards your goal with excellence as your end point, and persevere. Don't let anybody tell you that you can't do it, because you can. It's up to you. Your outcome is based on what you're, just like a computer. Your outcome is based on what the input is.
Yeah.
So
well,
you can do
thank you. Thank you both. It's been really great having the two of you on the show. Shonte, you as a Systems Engineering Technical Group Supervisor at the Jet Propulsion Laboratory out there in Pasadena, California. Stay safe from the COVID out there. Here, California has really ramped it up. Ron, it's always a pleasure. You and I, whenever we're together, a lot of times when you come to visit your dad and I'm at your house, we get into these conversations about flying and about technology, et cetera, that usually extend out. So it's really great to have you on the show. I think it's really fascinating. I could have done a show just with you about the 777 and the 787 and what that's like and all the systems that are involved with that, and everything. So thank you also for being. Thank you both for being on the program, the first show of 2021. And for the great advice and insight that you've given about aerospace and aviation. So you guys take care.
Thanks for having me.
Yeah, thank you. Thanks for having me, and take care, Vincent. Stay safe.
Absolutely. You guys do the same. And we'll see everybody next week for another edition. My name's Vince Mickens. Have a good one.
All right.